Hello friends, welcome back to Vedita Education. So in this video we'll see about Mathematics Grade 6 Algebra by Chennuru Venkata Vedita. Let's begin. So last we have seen something about literal numbers. Last video we have seen something about power of literal numbers. So in this video we'll see about variables, constants, expressions with variables. So first we have to know what is variables. With this small letter, with this small topic, we can make such a big topic with this. So if we can understand variables, we can easily form expressions with variables too. Now what is variables? We can in maybe some in diameter. Diameter is there, right? The diameter is d of the circle and radius r is given by the formula d is equal to 2r. See, we write some of the short forms. In diameter of a circle, we write diameter is equal to d and radius is equal to r. So what will be the formula? D is equal to 2r. Here means 2 into r. So this is the formula for that, for diameter. So we have used a single letter to denote big pic. We have just used a single letter. Which letter is that? D, R, are two letters which we covered diameter and radius. There are two letters which we covered diameter and radius. So in this, which is variable? Think just which is variables over here. Yes, the variables are so are variables. So we understood the idea of a variable. So we'll see definition of variable. Okay, see here, symbol means a single letter with various numerical values, means which has various numerical values. Numerical value like d can be 5, 10, 100, 10,000. It can be that much. It has so many values. It's called a variable. A symbol like d. In another example, same example, there's one more example. I'll show you that. We know area, right? Area we learned in mensuration. Area we denoted. So what we should do for area of a rectangle or area of a or take area of a square? If one side is C. One side is C. What will be the area? Area will be 4. Sorry, area will be C into C. Right?
So doesn't it have many values?
Like diameter
We took
A.
so in this area inside A what any number known as area. Any number it denotes. Not only C, any numbers. Numbers also it denotes, letters also it denotes. And now side. C. One side is C. So what will be the side area?
C
Which gives
C2.
right. Which gives C2. We have learnt about powers, right?
That is 34.
Now if they take one more example if you guys want. There is one more example which is so common. In maths only it's very common. I'll tell you. We know perimeter.
So perimeter we
Perimeter. In this perimeter,
P denotes a
perimeter with we'll write P. So if one side
of square is X.
so
If
for perimeter. So what will
the
be
P
equal to? For
S
us. Here we also observe that 4 is fixed value.
is always
4.
right,
But
S
and P is S and P are not fixed value. They depend on the
side of
size of
the
square. So you may be understanding what is square means a
what
variable. And I will explain
in this
examples
area.
which is one more topic constant is also there. I'll explain that. So we understood these 3 examples clear. So how to denote this is how to tell that these are variables. In this D, in this diameter is in first example. Diameter is D and radius is R. So diameter which is D, radius which is R. In this two, please only in this two which are variables. Yes, diameter and radius which is D and R variable. And here also we know that which is fixed value, which has fixed value or doesn't have fixed value. Here to have
Value you always
needs to not 5. Now what about D and R? D and R depends on the length or circumference. D and R depends on the radius. Sorry, of the size of the circle.
of the circle.
We understood it, which has fixed value, fixed value. Here, see, these both have fixed value.
Less
Is also having
fixed.
no. Only doesn't have fixed value. What about this C and C? They also doesn't have fixed value. They on the size of the square, rectangle square. Size of the square. Here also, which is variable? Yes,
A
and C variables.
A
C are variables. Here also, which are variables? Yes,
B
are
variables.
small we'll recognize the variables. A symbol which takes various numerical values is called a variable. A symbol, it can be a 2. These are known as symbols, not symbols like
Plus
those.
those
Symbols, those are math symbols. These are algebraic symbols. In A to Z, what we have? Letters we have. So in these symbols, which these are having so many values, like A can be 1, B can be 100, like that they are having so many values. That particular symbol means those symbols which have so many means various numerical values are called variables. So we have understood what is variables, right? So let's go for next topic. Now here we have another topic like variables only we have constants. Now in this constants, okay, a symbol having a fixed numerical value is called a constant. Now symbol, what is symbol?
A
Are known.
right?
So we know that variables should have various numerical values, but constants always have fixed numerical value. So in A to Z, um, in A to Z, fixed numerical means they only have one meaning, not at all another meaning. So you will see in constants, right? We have fixed numerical value which doesn't vary, which doesn't vary. So here, see here, in A to Z doesn't do they have fixed numerical value anywhere? Or think of 1 to infinity. Think about them. If we the A to Z doesn't have fixed numerical value, but numbers have fixed numerical value. So we can take these are also symbols, right? We can that these are also symbols. Not imagine, take that these are also symbols, but they have one can One should also be one. One is always one only, not 10. Like that, they have only fixed rate. If we take
3.
only 1 to 3 numbers are fixed, no, 1 to infinity are fixed, right? How it will be possible, I'll show you. If we take lakh, lakh is always lakh. It can't be 10,000. It can't be 1 lakh. Always lakh, but it not can't be 1 lakh 1. If we take 10, it won't be 100. But can it be 1? No. It is always 1, right? Same. These words which do not have symbols or numbers which do not have any fixed or do not have any various numerical value is called as constants. So you have understood so many examples of variables plus constants. So we'll go for next. Oh, we came to equations with variables. So we completed variables and constants. But here we started a new algebraic topic which is expressions with variables. So just recall in arithmetic means in recall in arithmetic. We recall in arithmetic. We have learnt about like this, like we learnt about this board mass rule. We have learnt about board mass rule, right? These expressions are formed from numbers like 2, 3, 4, 10, 100 and so on. These expressions, right? Like these type of expressions formed from numbers. To form a particular like this expression, to form we use something. What we use here? Board mass. We use board rule. This is actually if we use short like if we don't put bracket like this, we don't put we don't use bracket off. Okay, if there is symbol like bracket, we use. If there is symbol like bracket, we use BOGMAS, which stands for bracket of division multiplication now addition and subtraction. So this word mark stands for bracket of division, multiplication, addition and subtraction. So here are 6. But how to solve like this expressions? Solve it.
Yes, we can solve.
First, if there is a bracket, we first bracket inside, which is here. If we take example this 2 into 10, which gives 20, and
Plus 3.
now which is here addition. So just do addition, which gives 20.
We can
Into a particular number. Now, recall in arithmetic like these expressions I have told you. The to form expressions we use only 4 number operations of addition, subtraction, multiplication, division. For example, to form this number, we have multiplied 2 by 10 and then added 3 to the product. Examples of some of the other arithmetic expressions are 3 plus 4 into 5, minus 3 into 40 plus 5, 8 minus 7 into 2, 14 minus 5 minus 2, 6 into 2 minus 5, 5 into 7 minus 3 into 4. See,
like
bracket problem, first we solve the bracket, then we will do Damas rule. And here we have what we have here. 7 plus 8 into 2, 5 into 7 minus 3 into 4 minus 7. Type of problems are big, right? So we'll see with variables. Expressions can be formed from variables too. In fact, we already have seen expressions with variables. For example, 2 and 5m x plus 10 x minus 3. See, this point is very important. This will take this paragraph. This paragraph is the example of the expression, means definition of expressions using variables. So we'll see this paragraph. See, expressions can be formed from numbers, even variables. In variables and constants, we know constants mean numbers and variable means those alphabets. So in this, what we do is when expression like 3
m 5m.
these are expressions. A simple definition instead of this big paragraph, I'll tell you a simple definition. Those expressions which are not possible to solve anytime, which are not possible to solve are known as expressions with variables. This is a full paragraph. Now, if we want to solve them, we can't solve actually, because
3
can we solve it?
3 is here. Don't know
Value of
m.
If we know the value of m, we can solve 3. We can solve
This expression
same here, 5m. If we know this is the value of 5 only, but we don't know the value of
m here.
same, we know the value of m. So we can't form expressions. We can't solve them. These we can't solve them because if we don't value of one alphabet, we can't. If to some extent like I'll show you, these are able to solve. These expressions is two side. They can be solved, but we won't go now. We'll learn them later. Now, think we have already learnt about them. Like in my properties of multiplication, we have seen something 2 into n, 5 into m, like that we have seen, right? Those only. Those are also those only called expressions. We have already learned about expressions in that third part or second part we have learned. Now, these expressions with variables are obtained from operations of addition, subtraction, multiplication, and division on variables. Properties we have known, right? Properties, operations of addition, subtraction, multiplication, division. We have seen that that's they are saying. Now, for example, the expression 2n is formed by multiplying the variable n by 2. Right? Same only. We have known this also, we have knew this also. 2n is multiplied by n by 2. Right? The expression x plus 10 is formed by adding 10 to the variable x and so on. Great. Now, we know that variables can take different values. They don't have fixed value, but they are numbers. That is why in case of numbers, operations of addition, subtraction, multiplication and division can be done on them. One important point must be noted regarding the expressions containing variables. A number expression like 4 into 3 plus 5 can be immediately evaluated as 4 into 3 plus 5, 12 plus 5, that is 17. But an expression like 4x plus 5 which contains the variable x cannot be evaluated. Here the meaning evaluated means when we have something they can't be solved. Be evaluated means they can't be solved. Can be evaluated means they can be solved only if x is given some value. If example shown it for x 5 in bracket, we can solve a particular like 4 problem and solve, right? But why we can't solve this? Because we don't know the value of x. If we don't know the value of x, if we knew the value of x, if x is 7, 4 7, what is then middle x into? So 4 into 7, 27, 28, right? 28 plus 5, 33. So we got the value. Doesn't if they don't they didn't give the value of x, that they're not, it's not possible to solve it. It's not possible to solve. That is the meaning of evaluated. An expression like can be evaluated, for example, that only we have no. And see, this is very important. I've showed you, right? Literal numbers. So in this literal numbers, there are something more. We know that how they are formed and how we can form them. That we know. So again, we'll recall them because in this topic, expressions with variables, they are very important. See, now y plus 5. Y plus 5, the 5 is added to y, right? It's formed like that. And we know that changed column and not changed column, that we know. Right. Now t minus 7, if you want to recall it, you can please go to that to my second video, second part of algebra. You can go and see there. Now t minus 7, 7 subtracted from t. Okay, 10a is multiplied by 10, x by 3, x is
divided by 3.
minus 5q. Minus 5q means minus 5 is an integer. We have learnt integers, right? Minus 5 plus 5 minus 1, like that we learned, right? So now we know how we will form with that expression, with that integers also. So here q is multiplied by 5. Now what for 3x plus 2? First x multiplied by 3, then 2 is added to the product. Now 2y minus 5. First y is multiplied by 2 and 5 is subtracted from the product. So we have no right.
4x
5. That all we know. That is also an expression. Think of this, right? Again one expression. Think of this. Same problem. Similar problem here. Variable is also same, but the constants are not same, right? That's why. Now see here. Write 10 other such. Okay. This will do like a something more. We should also able to write an expression to give an instruction about how to form it. Look at the following example. Give expressions for the following. 12 subtracted from z. Z minus 2, right? 25 added to r plus 25, p multiplied by 16, 16p, y divided by 8, y by 8, m multiplied by minus 9, which is minus 9m, y multiplied by 10, and then 7 added to the product, 10y plus 7, n multiplied by 2, and 1 subtracted from the product, 2n minus 1. Now we'll see an example. Sarita and Amina decide to play a game of expressions. They take the variable x and the number 3 and see how expressions they can make. The condition is that they should not they should not use more than 1 out of 4 number operations, and every expression must have x in it. Can you help them? Sarita thinks of x minus x plus 3. Then Amina comes up with x minus 3. Next she suggests 3x. Sarita then immediately makes x by 3. Are these only 4 expressions that can get under the given condition? Next, they tried combinations of y, 3 and 5. The condition is that they should use not more than the operation of addition or subtraction and one operation of multiplication or division. Every expression must have y in it. Check if the answers are right. If in the following exercise, we shall look at few simple expressions have been formed. These expressions are very simple. See, like y plus 5, y plus 3, y minus 5, y minus 3, 3y, 5y, 5, y minus 3, y minus 5, 3y plus 5, 3y plus 3y minus 5, 5y plus 3, 5y minus 3. So, come in category of addition and subtraction for expressions. So, we will recall what we have learned today. We have tables, using variables, we have learned now how to forming expressions forming expressions
from
from instructions, giving instructions from formed expressions. We have learned those also, right? And we have recalled literal numbers. We have recalled them. So friends, if you have liked my video, please if you have enjoyed my video, please subscribe, like and share. And don't miss to press the red button, which is subscribe button. Bye.